8.3 is where we're actually going to start for Chapter 8. We'll do 8.3 through 8.6, but 8.4, 8.5, 8.6 are all like the same. And so that's going to be the back of this. It's conversions. So some of you, if you're going into the nursing field and have to take Math 124, that's basically what you're doing in Math 124 are these conversions. So 8.4, 8.5, 8.6 are all taught the same way. The difference is just, are we measuring a linear amount, a volume amount, or a weight? And that's the only difference, okay? So on here, this formula sheet, you guys can write all over it, but you will be given this exact same formula sheet when we take exam 4 and when we take the final, okay? So you'll be given these, you don't have to memorize these formulas or anything like that, yeah. Yeah, look at that. That'd be crazy. And I'm going to kind of probably stick to the basics, too. So some of the stuff we'll do in our notes is a little bit more difficult than what you'll see on the homework or the test, all right? So the first one is area. If you remember, area is a two-dimensional. Like if we want to carpet this floor or paint the wall, we have 2 dimensions, all right? Area is always measured in square feet or square meters, all right? So depending on what shape you have a different formula. So what shape is this? A rectangle. And a lot of us already know the formula for rectangles, but if not, we can just refer to the sheet. And if you look, area is just length times width there, okay? So I always write the generic length times width first. So, and if you do that, that's good because you show me at least you knew what shape it was and where to start, okay? And we don't know the area, so A is going to stay A, but what is the length of this rectangle? 7. What is the width? 3, okay? Does it really matter which one's 7 or which one's 3? No. Since you're just multiplying, it doesn't matter which order you do it in. So what's the area in this, guys? It's 21 square yards. Is that all right? So 3 times 7 is 21. They were measured in yards. So now if we were to cut these into yards, there'd be 21 yards, square yards there. You can use your calculator now, so you don't even have to know that. You can just put 3 times 27 in your calculator. And then we'll make note, too, that pi, we're going to use 3.14. All right, let's look at this. What shape is this? A triangle. And you'll notice the area of a triangle is 1/2 base times height. So the area equals 1/2 times base times height. But just for purposes, I think even when we're using our calculator, it's easier to use 0.5 for 1/2, okay? So I'm going to write 0.5 times my base of 3.8 times my height of 8. Is that okay? And if my multiplication gets confusing, feel free to use parentheses, okay? So we're just going to take 1/2, so 0.5 times our base of 3.8 times our height of 8. I don't even have the answer key out. That will help us. What do you guys get when you do that? 15.2. And we'll just pay attention to what they say. They say round to the nearest hundredths if necessary. But since that was just rounded to the tenths, we'll leave it at 15.2. What will be the unit? Feet squared. Square feet, however you want to say it. Is that all right? Okay. So then this shape is a circle. When you're given a circle, you'll notice that you're given 2 formulas. 2 times pi times r if you're given the radius, which is just from the center to the side, or just pi times d if you have the diameter that goes through. So notice this one is the diameter, so a equals pi times d. Let's write it as an exact first, because I know sometimes your homework has you do this where they leave pi alone, okay? So a equals pi times our diameter of 24, okay? So that actually would be the exact measurement. So that could be an answer, all right? So 24 pi miles squared could be an answer, all right? Or if they want an approximate answer, they want us to plug in different versions for pi. In this case, they want us to use 3.14. So we'll have 3.14, bless you, times 24. What do you guys get there if we round it to 2 decimal places? Am I using the right formula? I'm using the wrong formula. Sorry. Anybody questioning me? What am I using? Whoopsie. What does C stand for? Circumference. What are we supposed to be doing? Area. Sorry. I'm on the wrong track. Yeah, you're like, why are you using that got one. Call me out, guys. Okay. So anyway, that's circumference. It's good to know because guess what? That will be on the final, but not for this problem. Okay, so we want area. And area, guys, is only given to us in one formula, okay? So what do they have in there? They have the R. Do we know the R? We do, it's just not told to us. If our diameter is 24, what does that make our radius? 12, right? So remember, your radius is just half your diameter, right? So our radius is just 24 over 2, or 12, okay? So we're going to use A equals pi times 12 squared. Is that all right? If they want us to leave it as exact, that means leave pi as pi. But what's 12 squared? So we'll do 144 pi miles squared would be the exact answer. Or if they want an approximate answer, all you do is take this 144 times pi, but in for pi you would plug 3.14, and you just put that in your calculator. So A equals 144 times 3.14. What do you guys get when you do that? Yep, 452.16. Does that look okay? So that's an approximate.
So when it says the diameter, we're doing the radius. We just have to find what's after that. Then
yes.
Okay.
So, and that's what, like, even with circumference, they could give you one formula, 2 pi r, and always give you d, and you would just divide by 2 to get your radius.
So if we do either or on the test and the final, either one of those correct?
Well, either one of those is correct, but for area, you have to use the radius.
No, that's what I'm talking about.
Yeah.
The answers. Okay.
Yeah. Absolutely. On the final, I think they have you round everything, so I don't think they have you leave it as an exact with pi, but I think my math lab has you do both in this section, okay? All right, last one, guys. They kind of told us what it is. It's a parallelogram, and honestly, a parallelogram is just a squished rectangle. So if you look at the formula for area, it's just called base times height, but that's the same kind of idea as length times width, okay? So the base is always this, and then the height is how tall where that perpendicular is. So A equals base times height, so we'll just have A equals 13.4 times 8.2, and you'll just put that in your calculator, all right? Double check, I got 109.88.
Yep.
Does that look okay? And then our unit would be centimeters squared. Is that okay? So those are kind of your basics. What you're just going to want to pay attention to is that you recognize the shape so you know what formula to pull off of your sheet. Anybody have questions on once we write the formula, where things go? Okay. So let's go ahead and look at the top of page 2, guys. They are giving us word problems, and what we have going on with the word problem is that they're just going to have an actual object that is that supposed shape, okay? But after that, we're just going to do the basics. So it says a small rug is in the shape of a trapezoid. The base measures 18.4 inches and 21.6 inches, and the height is 5 inches. Find the area of the rug. I draw a picture, so I look over here. Trapezoid is just where the top is smaller than the bottom. And so I'll just draw it like this, where my top is a little bit smaller than the bottom. And then the base is, the smaller one would go on top, so 18.4 inches. And the larger one would go on the bottom, 21.6 inches. And the height is always just from the corner to the bottom, okay? And that is 5 inches. Do you actually need to draw it? No. It tells you base, height. So you could honestly just plug it right into the formula, okay? So I'm going to steal this formula from here. What it is, it's basically trying to take your base times height formula that a parallelogram is, but it's averaging your two bases. So it's 1/2 height times little b plus big B. It's important to make little b and big B in parentheses, so you do that first. So let's go ahead and write that down. So we have A equals 1/2 height times little b plus big B. Okay? So we'll have A equals 0.5, because that's just what I always do with my halves. What's the height of our trapezoid, guys? 5. And then what's our little base? 18.4. And what's our big base? 21.6. So even those that have scientific calculators, I believe you have parentheses, don't you? So you can still type it exactly how we see it. You can just put 0.5 times 5 times parentheses 18.4 plus 21.6 parentheses. Or if you're kind of iffy about that, you can always add these together first. So if you add them together first, you just get 40. And then that way it's just a straight multiplication. So it's just what you feel comfortable with. But with our calculators these days and them having parentheses, you can do it all at once. So when you guys multiply that, what do you guys get for the area?
100.
Exactly, isn't it?
Yeah.
And then it'd be inches squared because it's still area. Is that okay? F, a side of a square towel measures 6.5 inches. Find how many square inches of material is needed to make 4 towels. So it's a word problem where it's basically, let's just figure out how much we need for 1 towel. So let's figure out the area of 1 towel. And then if we're going to make 4 towels, we'll just multiply that by 4. Okay? So what's special about a square? All the same, right? So we know one side is 6.5 inches. We know the other side is 6.5 inches. So what is the area of 1 towel? If you go to a square, it's just side squared. But I don't like that. I like it to think of it as base times height. You know, it's just a special rectangle. But anyway, so this is side squared. So we'll just have 6.5 squared in our calculator. So when you square 6.5 in your calculator, guys, what do you get?
42.
42.25, does that look right? So what we have to realize, guys, is this is the material needed for 1 towel. So what do we need to do if we're going to make 4 towels? Multiply it by 4. You got it. So we're just going to times that by 4 in our calculator. And I think you get 169 square inches. Does that look right? Right here, though, when it says square inches, even though nowhere in here did it say area, square inches is hinting that they want you to find area. Okay? Because that's how areas are measured, right? In squares. All right. This next one's kind of interesting because you'll see how us as people see things a little bit differently. So what we have here is a shape. So maybe this is like your house, right? So maybe this is your house and then your garage. And so maybe we want to carpet the inside of your house or something like that, right? So how would we go about finding the area? Well, there's 2 ways. Does anybody see one way that we can do this?
Combine 5.5.
You can do 5 times 12.
What it's going to be, guys, is that there's 2 shapes going on. There's a way that we can cut this into 2 shapes, okay?
5.5.
So like this. You see that? Okay. So we can think of this as a square and then this is a rectangle. Or, I'll write a big or, you might have seen it like this. Either way, guys, you'll get the same answer. Okay, so this is 10, this is 12. All right, so if we're going to do it this way, what we have to do is we have to realize we have a square, right? Because we have a 5 by 5 square. And then we have a rectangle that's 12 kilometers long. The question is, what are these sides? And we kind of did this, I think, a while ago. All right, so if we have a side of 10, but 5.5 is taken up here, how much does that leave for the bottom part? What do we do to find that difference? Listen to the word I said. What do we do to find that difference? Subtract it, right? So we're going to take 10 and take away the 5.5 that's used for the upper part to figure out what's the lower part. What do you guys get when you do that? So that's 4.5, okay? So we have area 1 and area 2. So our area is going to be a square, so s squared, plus a rectangle, length times width. Is that okay? A square, and I'm showing like way more like equations than you need to. If you want to jump right to it, you can. So area 1 is a square, area 2 is a rectangle, okay? So what is the side of our square, guys? What are the sides of our square? 5.5. So we're going to take 5.5 squared. And then what is the length of our rectangle?
12.
12, right? We didn't do anything to that. And then what is the width we just calculated?
10 or 4.
4.5, right? I'll maybe write that. That was 10, take away the 5.5 from up above, right? All right, so we can just do this in 2 chunks. Let's do 5.5 squared and see what the area for the square is. I got 30.25. Does that look right? And then if you take 12 times the 4.5, you get 54 even. Is that okay? So we'll take the area of the square plus the area of the rectangle and just add them together, and you should get 84.25 kilometers squared. Does that look okay? If you did it this way, did anybody see it this way? You would get the same kind of idea. You just have 2 rectangles, okay? This rectangle would be 5 by 5 times 10, okay? Because we didn't do anything to him. He's a width of 5.5 and he's a length of 10. And then we'd have to figure out kind of a lot on that one, okay? He would still be 4.5 because we'd have to take 5.5 off of 10. But then we'd have to take 5.5 off of 12, and we get 6.5 there. So this is 6.5. So this one's a little bit more of a difficult way to do it. Guess what you get when you do that? 84.25 kilometers squared. Okay. Are there any questions on area at all? All right. So the last page is jumping into 2 measurements we haven't dealt with yet. One is volume, and volume's 3 dimensions. So like, you know how I said linear is just measuring this line, area is measuring the carpet. What if we wanted to fill this room with boxes, right? So like cubes, like Christmas boxes, okay? So we have length, width, and height now. We have 3 dimensions. So kind of keep that in mind when we do our unit. Our unit will now be cubed when we're doing volume. Surface area is just like wrapping paper, right? If we wanted to wrap the whole room, how much wrapping paper would we need for the ceiling, the walls, and the floor? So it's the wrapping around, okay? So volume is cubes, and surface area is squares, okay? It's like wrapping paper. And volume is total inside. Like think of a pool. The volume of a pool is how much water we could fill it with. All right. But again, all of our formulas will just be right over here. We're just going to be looking at the 3-dimensional objects, though, so the bottom half of the formula page, okay? So it says, find the volume and surface area of each rectangular solid or cube. Round to the nearest 10. So the first one's a rectangular solid. So if you look at this, we have 2 formulas. One for volume, and it's just taking off of what we already know. We know a rectangle's length times width, right? But now we have this 3rd dimension where we have this little height going on here, okay? So that's just length times width times height. So we're throwing in a 3rd dimension there. He's pretty easy. Now, if you look at surface area, it looks complicated, but it's not, guys. All it's doing is taking into account the area for each little part. So this is a little square, and this is a little square. And so that's height times width, but we have 2 of them. So that's where that comes with. You know what I mean? And this is length times height, but we have the front and the back. So that's where 2LH comes from. So it's just taking into account that a cube, like a present, has 6 sides. So what would be the area of the ends? Would be the areas of the front and the back. What would be the area of the top and the bottom? That's all that's doing, okay? So I don't know if you want to try to draw it. I'm not the best drawer, so I like that it labeled L, W, and H. So I can just plug it right into my formulas, okay?
Surface area and
Volume.
the same?
No, I wrote it right up here. So volume is the total of the inside. Like if we want to fill this room with boxes, how much total is the inside? Surface area is like wrapping paper if you just want to wrap around. So it's the area of the outsides. So volume is like you're filling a pool with water. Is that okay?
Yeah, so what, like, surface area is pretty much just like finding the area, right?
Area of all the sides.
All the sides.
Right? Because it's 3-dimensional now. Like,
Okay.
if it was a rectangle, you just had one side, but now it's a rectangular prism. We have 6 sides that we have to wrap.
Okay.
Okay?
Got it.
So it's still measured with square units. It's just we have multiple sides to find out. So write kind of small. We'll do the volume right here. Volume's length times width times height. And guess what? They gave us all right in the right row, okay? So volume is length, 7.9, times width, 4, times height, 6. Not too bad. We're just going to multiply straight in a row and make sure our units are cubed. What do you guys get rounded to the nearest tenth? 189.6? Does that look okay? And then since it's volume and we have 3 dimensions, it's inches cubed. Like how many little sugar cubes could you put in this? All right, surface area, again, it looks complicated, but it's not trying to be. It's just doing the areas of each of the outside squares, but each of them have a pair. So that's why it's 2, 2, and 2, okay? So we have surface area is 2 times the length times the width, so that's the front and the back, plus 2 times the length and the height, so that's just the top and bottom, plus 2 times the width and the height, and that's just the sides. Okay, and I'm just stealing that straight from the formula sheet, straight from there, okay? So we'll just fill in our L, W, and H where we need to fill it in. And again, the 2 is because everyone has a pair, all right? So surface area is going to be 2 times the length of 7.9 times the width of 4, so that will give us the area of the front and the back of the box, plus 2 times the length, 7.9, times the height, of 6, so that will get the area of the top and bottom. And then 2 times the width of 4 and the height of 6, that will give us the area of the 2 sides. So I think you can put this in your calculator straight like this because it should know order of operations, multiplication, and then multiplication, multiplication. But I get paranoid. So I do all the multiplications individually and then I'll add them up. So has anybody put it straight in their calculator, or are you guys doing it individually?
I did it in
Okay, so what did you get for 2 times 7.9 times 4?
63.2.
Perfect. And then what did you get for 2 times 7.9 times 6?
94.8.
And then what did you get for the third one?
48.
48. All right, and so when you add it all up, you get 206.
Yes.
But even though we're dealing with a 3-dimensional object, we're just talking about the area of the outsides. So we're still just measuring in square inches. So if you just see the word area, even though it's surface area, it's still an area, so it's just measured in square units there. A cube is even a little bit easier because all the sides are the same, okay? So it's just length times width times height, but the length and width and height, they're all the same. So it's just s cubed. And then it's all 6 sides, but all 6 sides are the same. So they found the area of one side, s squared, and multiplied it by 6 if you look at it, okay? So all the sides are the same, so length, width, and height is just s times s times s, or s cubed. And then all the sides are the same, so the area of one side is just s times s, or s squared, but there's 6 sides, okay? So for the volume, we'll just have s cubed, so we'll just have 6.4 cubed. If you round to the nearest tenth, I got 262.1. Does that look right? And that would be centimeters cubed because it's volume. It's filling in the inside. Callie, are you okay?
Yeah.
And then surface area is just all 6 sides times their area of s squared. So it's just 6 times the 6.4 squared. And again, you can put that in your calculator straight like that. It will know that you're only squaring the 6.4 as long as you put parentheses around it. I got 245.8. Does that look right? And then since it's area, it's squared still. All right, so then the next couple are where it gets kind of nasty because they start getting to be more difficult shapes. For purposes of the test and even the final, they won't be horrible. I'll tell you which ones are like really bad. Like I think the cylinder's bad and the cube and pyramid are pretty bad. The sphere's not bad, and these two aren't very bad. Okay, so we're going to do the exact same thing, guys. We're going to find the volume and surface area of spheres now, which are based off of circles. Okay, so a cylinder. When I think of a cylinder, do you guys ever buy the old school oats?
Yeah.
That's like what I think of as a cylinder. And so I've been making overnight oats a lot, and so I just have this, I should bring it in. So you just have this huge tube. What it's based off of is all it's doing is just using the area formula for a rectangle, for a circle, pi r squared, and then adding that third dimension of height. So it's just pi r squared times h, okay? And then as far as surface area goes, it has a top and a bottom, so there's 2 pi r squared, because you have a pi r squared on top and a pi r squared on bottom as far as area goes. And then they were able to calculate that. Guys, that's just like a rectangle like that, right? So somebody was able to calculate, okay, well, a rectangle is just length times width, but in this case, it's a little bit more complicated because the length is the circumference, 2 pi r times h, okay? And again, none of this has to make sense. You don't need to know where the formulas came from. You just need to know which formula to use and what r is and what h is, okay? So looking at this one, we have a sphere, and notice what it gave us, a diameter, right? So what should we do to that diameter so we can get the radius? Not square it, but we're going to divide it by 2. So we'll have 6 inches, all right? So the sphere, again, I'm not a good drawer. If you can draw a sphere, look how creepy that is. That's my sphere. So we're going to have this radius of 6, right? So how do we find the volume? I just go over the volume, and the volume is, what is it, 4/3 pi r squared, or pi r cubed, right? That gets hard to read. And again, somebody was able to find that out. Somebody derived that, okay? So what we're going to just do is we're going to put 4/3 pi, leave them alone for now, and we're going to put the 6 in for our radius. So V equals 4/3 times pi times 6 cubed. All right, so what is 6 cubed?
36.
Okay, so we'll do 4/3 times pi times 36. Is that okay so far? No, 36, 6 cubed should be
Oh.
216. Yep, I just realized that. Because that would be 6 squared, right? So 216. Okay, so how do we do this on the homework? Again, this is what gets complicated because my math lab wants you to give it as an exact answer, meaning leave pi there, and as an approximate answer, meaning put 3.1 in for pi. But notice right here we have pi, but we still have 2 numbers we can multiply. So for the exact answer, what I need you guys to do is in your calculator, take 4/3 times 216. And you can do that on your calculator by 4 divided by 3 times 216. And you should get 288. Is that what you get? So the exact volume is 288 pi inches cubed. You guys see what I'm doing?
And you said that's how.
My math lab, because whenever they say exact, yeah, they'll have both. So I'm going to put the second one here in a second. So the exact volume always means leave pi alone and do all the other math that you can, right? So we could cube 6 and we could take 216 times 4/3. But leave pi just kind of hanging out. So that's the exact volume. And then the approximate volume is when they want you to put 3.14 in for pi. So at this point, all you have to do is take 288 times 3.14. And what do you get?
904.32.
You got it.
So when it says exact
Leave pi in there, and when it says approximate,
or approximate, that's what.
that's when you plug something in for pi. Yep. And I know there's not a whole lot of room, otherwise I'd be labeling these. So this is the approximate when you plug something in for pi, and then this is the exact when you leave pi alone. Okay? And we're going to do the exact same thing for surface area. This is interesting. If we had time, I'd do it, but one of my coworkers teaches math for elementary teachers, and she brings in little clementines, and she has them peel them, and she proves how they the surface area matches 4 pi r squared. It's weird. It's cool. It's like you actually physically see where it comes from, and then your room smells really good as well, right? So let's look at the formula. It's just 4 times pi times r squared. It's just 4 circles. So we have 4 times pi times r squared. So what we're going to do is we're going to leave 4 and pi alone, and we're going to put our radius of 6 in. And this is what I'm talking about. For the exact, do the math you can. What can we do? We can take 4 times 6 squared. What is 4 times 6 squared? 144. And who's tagging along behind it? Pi. So that's 144 pi inches squared. So this would be considered the exact answer because we haven't done anything with pi yet. All right? What do we need for the approximate answer? Just do the math
but with 3.14. So what is it when they're shoved right next to